I just want to put this out there too. When it comes to elevation changes in your piping systems as well, if you're still trying to figure out the head loss, which is units of meters, it's just another thing you're going to add up in the right at the end of all of this. You still have to do all your major calculations. You still have to do all your minor calculations. But if there was elevation changes that was doing like step function types, I go like up, then straight down, then straight up, then straight down, that would be the situation where you just add these things, where you just add up those changes in heights, and then you would be able to see. And there's a net effect thing that happens if you were to go up and then you fall down, right? If you have to go up, you have to work against the force of gravity. When you're going down, right, gravity's going to do that work for you. So you can have these piping systems that go up and down, and you're just going to consider the sum, right? The sum of this, so the net effect of going up and then down. Because going down has benefits while going up, pumps have to work harder on that. So just maybe to put that clear, sometimes people don't go up and then go down if that comes up in some type of problem. You can just still add this on to that total head loss for a pipe in series. But last, we wrote out sort of the series equation that you can always write out. I always write it out for pipes in series. We have, let me get this right. So I will be explicit for this one, which is a function of the Reynolds number. So it's a friction coefficient. Then we have Li over Di. There's an 8 here. Squared. Let's see if I have this right. So for in series, if you're going right expansions and contractions, even if they did it, that would just really change the losses that are occurring. Again, remember, these could be effective lengths that I've calculated previously. The diameters of the pipes are, right, could be all given, they could not be given. And then here is this sort of thing I want to point out when it comes to these friction factors. They're functions of a Reynolds number and this roughness, right, and the roughness, which is a function of the diameter. So that's where this nonlinearity comes from when you're trying to solve for these things. Because, right, Reynolds can be written in terms of, right, Reynolds is, what was Reynolds number, right? Rho V, right? So there's even the diameter in there, so clearly it's a function of diameter. And then, right, this could be written in terms of Q. So you can see how these friction factors are, you can think of them as functions of the flow rate and functions of the diameter, because the material could be given. You could list out all these inputs. This. Close. So I think I wrote a bunch in the notes about this idea of it's good to realize what you can and cannot calculate in this based on this just one equation. You're just writing out one equation for head loss, and this is just a bunch of different terms in there. So the question of not knowing 8 diameters and trying to use this equation to figure out what those 8 diameters are, it's not well posed. You can find, you could search and find solutions for that, but there's not like one true solution that exists, and that's because you'd be trying to figure out 8 diameters given one equation. The flow rate even has issues. Oh, it's pretty squared there. The flow rate has issues too, just because of the fact that, right, you picking a flow rate changes each individual one of these friction factors by some amount, but it still could be calculated as well. So maybe put that in words. If you just don't know, if I don't know one of the diameters in this equation, then it could actually solve for something because it's now one equation and one unknown. But multiple unknowns, so if let's say I don't know you have this question that you don't know 8 diameters, right? Some set of them. Right? And you're trying to say what these diameters need to be given using just this one series equations. You can't really do it because it's now you're using one equation to find 8 unknowns. But that happens a lot when people are trying to do hand calculations for these things. They'll just try to use this one equation to somehow figure out what these 8 diameters are. So I just wanted to make that clear. I've seen that a lot. Just this idea of understanding that you have one equation, meaning that you can only solve for one unknown. If you want more unknowns, that's this idea of just putting test diameters in there to try and come up with an equality for something like this.